guys today about basically what's going on at Pasaquan. Sorry. Basically just going to tell you what's going on at Pasaquan and just give you a few shots of what's going on. Pasaquan is kind of different for us. We're working actually with 3 different crews of people. We have Peter's crew at Parma and Tim's crew working on the house. So here's just a picture of us all before we knew what we were in for. This is just kind of a brief site map, shows you just how many areas that we're going to be finishing up on and working on. Well, this picture right here was my first kind of introduction to what kind of problems we were going to be facing here. I think it stems from the fact that a lot of people helped Eddie create the site, but there are a lot of different formulations in the mortar and the cement that were used, and some of them are not as stable as others, and there's a lot of leaching of lime and coming out of the pieces. And our first introduction was these whole areas that were kind of like icicle areas, or basically it's what you would call a stalagmite or stalactite, same kind of idea. This was our first indication that pretty much a lot of what we were going to be working with is not very stable. Jerry already showed that. This is this is another kind of just showing you kind of what we were in for. So our first thought process, that's a bad picture, was we were going to clean things off and see exactly what we were in store for. So that involved, you know, the first few weeks, pressure washing where we could, chemical cleaning for other areas, because a lot of the structure is basically cement or brick structure where he's come back over and put a very thin layer of concrete. So some areas are stable enough to pressure wash, but a lot of areas aren't. You would just shear them right off. They're not really mechanically bonded well, so you had to do mechanical cleaning and chemical cleaning. And at that point, we were able to actually remove some pieces that were very loose. And you can see here we're taking them off and numbering areas where they go. And kind of get an idea of how many pieces. Some of the sections we were into the 100, 150 category for each pillar, just pieces that we were finding. The next thing we started doing was digging trenches around everything. Due to the number of cracks and the amount of settling, we kind of had a feeling, and unfortunately it was confirmed, that a lot of the structure was not sitting on stable bases or foundations. The other reason we dug, we were able to find an awful lot of the missing pieces from that skim coat when we were digging, and so we wound up picking those pieces out of the dirt, sifting through the dirt, and trying to get all these pieces almost like an archaeological dig, and then try to put it back together in these huge puzzles. Yeah, that's just kind of showing work. The other thing we found was the site has changed a lot over the years, and one of the things you could see here is just a little medallion. These were all buried underground, and under some of the pieces, he's actually built other pieces over top of them. So that all had to be documented and figure out, you know, what precisely are we going to do with these things. You know, we've got original artwork underneath the artwork that we're aiming to preserve. The other thing we noticed right away that is typical of these sites, and it was a problem for this site especially, was, I'm showing a picture of this wall, you can see the cracks, that tree. We have a lot of problems with trees and planting and growth. At a lot of these sites, people plant trees, they plant plants, everything too close. It looks nice and beautiful, but unfortunately it's stuff that's not really going to be conducive to maintaining the site. In this case, that tree actually had to be removed, but it is part of the site, so, you know, what do? We've talked with some of the local arbor societies, and we're going to be replacing the trees, I believe. They're going to be helping us out with other varieties of oak trees that have smaller root clusters, and maybe actually moving them back a little, try to maintain the look of the site. But at the same time, we need to consider what's going to happen in the future in maintaining these sites. We can't have trees that are so close to the walls. As you can see, they really start to tear things apart, and a lot of the walls of this site have suffered from that. Here's one. That's actually about an inch worth of space that these walls, these long walls, have been moved out of alignment. So before we can do a lot of our work, we have to stabilize them. So we came up with the idea that we'd use stainless steel metal plates on the top. We were lucky in this case, the top of these walls was covered with tar and metals, so we can bury these plates so you can't see them. And this is kind of showing you how we kind of start to align the walls and put all these stainless steel plates in to get everything so it lines up. And at that point, then we can actually start fixing the skins of things. And in some cases, you have the walls are so out of joint and out of whack and falling over in some cases, we needed to figure out ways to pull them back together before we could even tie them together. And so you wind up with these huge contraptions of straps and slowly pulling things. You can't pull everything all at once. You have to pull everything very slowly over time. This kind of shows you. We were able to drill through these bricks. A lot of these, this is why I was talking about that thin coat that just comes right off when you're looking at it wrong. And this shows you from the other side how we're pulling on 13 different sections. These are our local help having fun. This is another wall that kind of just shows you what it's looking like when you first start. It's a mess. There's usually tons of biological growth. In this case, this wall also has repairs that have to be removed. Original art was covered over by well-meaning people that have tried to maintain the site, but it's something that we're going to have to get rid of. And you have to be fair. If they hadn't have done that, the wall might not actually be there. So you can't be too upset with someone just trying to help, This is more of what it's looking like when it's clean. You'll see there's lots of areas that we're dealing with. Right here is another common problem we're dealing with is the bricks in the wall are completely deteriorating, and they all have to be coated or filled. We try to use, we try to not be that invasive, and usually we try to use some consolidants in something like a methylethocetone solvent that can get into things and then replace the interiors with some kind of consolidant, usually a plastic. And this is just showing kind of the work we're doing. I think you've seen this picture. So then what happens next is, one of the problems also these walls have is they're solid walls with no expansion joints. So we can repair the entire thing as a completely solid wall, but we're going to run into problems again. So here we're using the actual, some of the existing stress cracks, and we're filling them with a polyurethane caulking that we kind of have a mixture that we mix with sand and kind of put that in. We try to be very minimal about that, but we want to make an expansion joint. We don't want to create an area that's just going to crack again and have to be repaired. And this, at that point, once we get the walls stabilized, coated, and ready to go, we hand them over to the Parma people, and they work their magic. Yeah, you can kind of see some of the. Would you like to talk now? Sorry, I was kind of nervous. I know it comes as a surprise to people who know me, but I actually don't like to talk.
All right.
Okay.
All right, we're going to turn it over to Peter now.
First I have to do this. Okay, let's see if I can get this right.
Hello there, all you people.
I'm Peter Schoenmann, and I'm a painting conservator in front of the mic at Parma Conservation. Here I'm annihilating ions for a group of 8th graders. But we usually work on easel paintings such as this. My wife, Elizabeth Kendall, worked in Italy for 16 years. That's why we're called Parma, because she lived there. And her expertise is in old master paintings. But we work, we thought we worked on a lot of large things like murals. This is a mural from Chicago Public Schools. It was by Ralph Henriksen, painted during the WPA. For the Postal Service, we've conserved well over 200 Treasury section murals across the country. But nothing really prepared us for this. 6 acres of psychedelically painted outdoor sculpture, nearly 20,000 feet, 20,000 square feet of surface area. And, of course, you've seen what's happened. Eddie was ever maintaining his creations, even as he created new ones. And, when he died in 1986, people just couldn't keep up. Here's more biological growth on the exposed concrete. You've seen this one again. This is the stalactite lime. Concrete is very, very permeable, which is a huge problem for the paint and concrete alike. Some areas were so weather-beaten that there wasn't anything at all except for some lichen or moss growing on it.
I must find some way, somehow, some help to keep this thing up.
Yes, that was his plea in 1986, and I wish he could see what's going on now. This is John Salas. He's another painting conservator at Parma. He's an artist in his own right, and I think Eddie would probably think that he was a Pasaquan from the future who had come to answer his call, and I think he feels the same. Another thing that's special about John, I've known him for 25 years. We went to college together, and we also worked in a coatings research lab in St. Paul, Minnesota, color matching vinyl plastisol. It's the stuff that makes up tool grips and hog flooring, mud flaps, you name it. It can be made to any shore, any hardness or softness. We worked for this guy. He was an old chemist, Old Man Los, and his claim to fame was, anyone recognize this? Creepy crawlers. Actually, he didn't invent the creepy crawlers, but he sold the goop to Mattel that supplied all the creepy crawler kits. So that's a little background. So back to the future, here we are. It seems like we were a little bit destined to work on this project. We set up our color lab in July at the site at the guest house. And for pigment analysis, we were really fortunate because we found boxes and boxes and boxes of colorants. These are pure pigments ground in linseed oil that you used to be able to buy at a general store. They're not intended to be used as paint on their own, but you use them to tint a base. And we found some of the bases like this. There was a big can of pure linseed oil. And we found some alkyd resin and some other enamels. So in the heat of July, we're outside in a tent and we're making swatches. That's Dan Smith from the Kohler Foundation. He retrieved a painting from the house that needs help also. It's like completely missing. So we laid out the color and they had names like American Vermilion, Chrome Yellow, Chrome Orange, Chrome Deep, Flake White. Okay, these are all lead chromate, highly toxic and long ago banned by the EPA. But the one thing about these chromate pigments, even though that some cases they were underbound because we suspect he was digging right out of those pigment dispersions and using that. There's a video where I wanted to find him saying pure color because that's what he loved. The lead chromate, the high metals pigments actually held up a lot better than any other of the pigments, as you can see here. Yeah, you can still see the yellow. But since it's outdoor and we know that, paints you know, like the alkyd resin, like the linseed oil, you know, as they oxidize, they become more brittle, and that was part of the problem. So, you know, we knew that we needed a paint that was going to be permeable. Permeability was a huge factor, and we needed a paint that was going to be compatible with the Objects Conservator's consolidant, which is ethyl silicate, basically. So we called that manufacturer, and lo and behold, they had a product. You know, they didn't make it very often, but you know, it was compatible, and it had a perm rating of 80. We happened to be working with a Sherwin-Williams rep at that time also, who wanted to sell us their masonry coating. And I told him, well, we're looking at a perm rating of 80. He's like, what? 80? He's like, I don't even believe you. You know, I know we have the best product on the market, and it has a perm rating of 8. And I don't even know why you'd want a perm rating of 80 unless maybe you were going to be painting the Hoover Dam. So that's basically what sold us on this paint base made by Prosaco. It's a breathable masonry coating. And this is just a little chart that gives you a little bit of an idea. Is this it? Oh. Well, anyway, the bottom line shows like a water-soaked log, and its drying rate over the course of days. The top line shows a coating with a perm rating of like 6 or 7, 6.5 or 7, 6.7. And the one that's closest in line to it has a perm rating of 58. So, you know, what we're putting on the concrete now, it's like it's almost not there. The next, you know, problem we had was with the pigment. We couldn't use those leaded pigments, you know, because it's toxic for us and it, you know, not very available. But, you know, we wanted to come as closely as possible, so we were looking at cadmiums. You know, like this cadmium sulfide yellow. But cadmium is very expensive, and in the very beginning, we were putting about $200 worth of cadmium into every gallon of paint that we made. We finally struck a deal with Robert Gamblin, who agreed to sell us, you know, if we bought in bulk by the pound, he would give it to us at a decent discount, which we took. So here's John Salas in our color lab, and so we had to make our own pigment dispersion, and we used ethyl silicate, not ethyl silicate, ethylene glycol, which is, you know, it's basically antifreeze, but it's a good dispersant, and so we were mixing that in. The important thing was to get the consistency right. You know, pigment to that vehicle ratio was roughly 2 to 1, but it varies depending on the absorption of the pigment. And you know, we use high shear mixers on site, and we also have a Red Devil paint shaker for when we add the pigment to the BMC coating. So this was our test wall. This is the first wall that we worked on, and it was quite a test because originally Eddie's paint had a glossy look to it. You know, he was using enamels, he was using alkyd resin. You know, never mind that the extreme weather conditions, you know, 11 days of rain, you know, very hot sun, in a few years turned that sheen to a matte finish anyway. You know, we wanted to come as closely as we could, but, you know, in the end, the product, the performance of the product prevailed, and the Pasaquan Preservation Society, once they saw what the paint looked like, they agreed to. It doesn't reflect anything, you know, it just looks like pure color, just like Eddie liked. And everyone agreed that he would have approved. So to aid in our color matching, we used Pantone. We had interns and volunteers go around and map out every vestige of color that they could find on the concrete before they started power washing. And since the concrete forms were incised, it was a little like painting by number. Once we, you know, settled upon the color that it needed to be, you know, it's not completely easy. I mean, you have to have facility, but it's nice that it's kind of laid out for you. And we also had tons of historic photos if we ever had a question. You know, keep in mind that as Eddie was maintaining the site himself, and afterward volunteers would come and help maintain the site, the colors would all change. We found sections that had 7 layers of different colors of paint. So, you know, you kind of have to make a conservation call. For example, here's a sample of mountains that we assumed was interior because we didn't see anything like it on the exterior, which looked like this when we got there. But once we realized that that mountain range that I previously showed you, you know, actually represented a corner of this wall, we went ahead and made the call to reproduce it to that stage. The background color as well. Fred Fussell tells us that in the 80s, Eddie wrote a grant, received a grant and bought a lot of black paint to just maintain the background color when they had originally been more bright blue. So we kind of made a compromise. You know, we worked with the Preservation Society to sign off on our color choices in some cases. In some cases, the mountain range, you know, stayed pretty close to what we think volunteers had repainted, simply because we didn't have good enough references to do anything differently. So this is just a final sequence of what we do. The wall is when the wall is completely repaired, consolidated by the objects conservators, we come in and start laying down the colors that we had cataloged. And we come up with something like this. This is just a picture of our team. You know, we're really fortunate to have, you know, great conservator co-workers and volunteers and, you know, local talent, as Terry mentioned, you know.
Here's how it's gonna end.
That's how it's gonna end. I thank you so much for your time.